calculators. And go to y equals, clear what's there. Type in these two equations. So x plus 5 and negative x plus 1. Okay? X plus 5 and negative x plus 1. So let's look at your graph. If your windows aren't normal, zoom 6. I don't know how mine are. Mine are normal. Okay. So this graph has how many solutions? Remember, what is a solution? Intersection point. So how many intersection points? 1. So this graph would have one solution. If we do just a quick sketch here of what we see a line like this, and we see a line like this. Okay, so we have one solution. Now notice, what do you notice about, I want to draw your attentions to the slope. Are the slopes the same on this graph? These equations? No, they're different. They have different slopes. As long as you have different slopes, you will always have one intersection point. Okay? If the rates of change are different, no matter what, there's going to be one solution. Okay? Let's graph these two. Now, what do you notice about these two? Same slope, right? But what about the y-intercept? Same slope, different y-intercept. So let's look at the graph. So what happens when we have the same slope? Here, y equals, clear what's there, type in these new equations. 2x minus 8, 2x plus 6. And graph that. What kind of lines are these? Parallel. So as long as the slopes are the same, so remember back from last unit, parallel lines have the same slope. Same slope, different y-intercept, because we don't want the same line. Okay? So same slope, y-intercept are going to have how many solutions? What's a solution again? 0 solutions or no solution. 0 or no solution.
So on the text, we're going to automatically see a question that has the same slope.
Nope, because let's look at one more case. Okay, if it has the same slope but different y-intercept, then you can automatically say no solution. But if it, let's look at this equation here, the second one. In order to graph this, what do I have to do? Add 2y to the other side. We need to make it y equals. Remember that? Good times. This is a good review before your quiz. 2y equals 6x minus 4, and then divide everything by 2. Y equals 3x minus 2. So what do you notice about this equation and this equation? Same. Same slope, same y-intercept. And so if this, so really, if you have the same slope and same y-intercept, it's one on top of each other, the same line, right? I graph both. I'll draw one color, and then it's going to draw the same color on top. So there's the blue. And then, what's there? Oh, there's the red. See, it's overlined. Here. Well, what you could do is you could make it bold. So you can go over here and make one of them a bold line. So you just push enter, and you can keep pushing enter. Will change the type of line. I think you just push enter once, and it makes it a bold line. Okay. On these versions, you'd have to go down and then right arrow over until you see the bold one, which is right there. Okay. So you can make it bold. So it draws one line and then the bold line over top. but mine's, yeah. Okay? So these are, you do have different colors, it's nice because you can kind of draw them at one on top of the other, but it's the exact same line. And so, again, solutions are the what? Intersection points. Solutions are intersection points. So if we have the same line, how many times are they intersecting? How many points intersect? All of them. All the points intersect. Right? They are the same line. So how do we say multiple in math if all of them? What's a good word for all? Okay, another word for eternity in mathematic terms. Infinite solutions. Okay, so when you have the same slope, same y-intercept, infinite solutions. Same slope, different y-intercept, those are parallel, no solution. And as long as the slopes are different, one solution. So one. So that's the gist of today's lesson.
Wait, that's it?
That's the gist of it, yeah.
Oh,
We'll do a couple things, but really, okay, so if we have one solution, to do a little review, we have intersecting lines. Slopes are different. Does it matter about the y-intercept? No. So y-intercepts, doesn't matter. All that matters is as soon as the slopes are different, there's one solution. Yeah. Okay, we're only studying linear two lines. So if we're dealing with a quadratic, that's math 20. So you can have two solutions, one solution, no solution, right? So, but we are only starting, that's grade 11. Grade 10, we're just doing two lines. So it's as exciting as once, none, infinite. That's as exciting as it gets. That's my hand. Okay, no solution is when we have parallel lines. So slopes are equal and intercepts are different. The y-intercepts are different. And then another word for two lines that are identical, coincident. Okay, lines are coincident means they're identical. There's the same line. Same line. So that means that the slopes are the same. The intercepts are the same. They're both the same because it's the same line. Everything's the same. Okay, so looking at this, how do you, if everything revolves around the slopes, all three of them, to know if it's parallel, perpendicular, not perpendicular, parallel, coincident, or different lines, in order to know the number of solutions, we need to know slope. In order to know slope, our equation needs to be y equals mx plus b. So if we have two lines like this here, and I want to know if it's going to have, like how many solutions they have, we need to make them all y equals. First equation, is it y equals? No, so let's change it. Let's zoom into it. Okay, first step, move the 3x, yeah, minus 3x to the other side. So we're going to move it. And then divide everything by 5, okay? So y is equal to negative 3 over 5x plus, no, 3. Okay, so these lines, tell me about their slopes. They're the same. Tell me about their intercepts. They're different. So if you have same slope, different intercept, what kind of lines do we have? Parallel lines, and so if they're parallel, how many solutions? 0 solutions or no solution. Solution.
What?
No solution. Oh.
Yeah.
Bad word?
No clue.
Okay, try the next one. Okay. Try the next way. Figure out if there's no solution, one solution. Oops. So if you're solving algebraically, as long as you actually get x equals or y equals, like something's eliminated and you get an answer, that's going to be one solution. Okay, so if you're algebraically solving, and I get here 5x equals 7, x is 7 over 5, right? Is it giving me an answer? Did I get an answer for x? Yeah, so I just need to find the y. That would be one solution. I can actually work it out. What happens is if you have a situation like this, okay? These two lines, if you actually rearrange them, they're parallel lines. They're going to have the same slope, different y-intercept. And so parallel lines are going to have how many solutions? Parallel. None. So if I try to use elimination here or substitution, what happens is the x's will cancel, 0, and what else cancels? Y. So we're left with 0 equals, in this case, -3 when we subtract. So does 0 ever equal -3? No, it's not possible. And so if that ever happens algebraically to you, that's no solution. Okay? Because 0 can never equal -3. If you're solving algebraically, and the lines are the same, guess what's going to happen? 0 is going to equal 0. Okay, everything cancels out. That's because of the same line. If you ever have 0 equals 0, that's infinite. Those are the same lines. Okay, so if you do end up wanting to solve algebraically to see if there's one solution, it actually works. If you ever get this where x and y both cancel out, it's going to be either 0, 0, 0 or infinite. Yeah. You have the option every time. So if you want to make it y equals every time, you could just plug it in your calculator and see how many solutions there are, right? Algebraically. Okay, number of solution questions, I'll just say it now. They're just going to be multiple choice questions. Okay? So you could do whatever you want. Okay? Because I'm going to save my written response for actual answers. No, so not a number of solutions, just what is the solution? There will be an intersection point. Solve algebraically. Okay? I don't think we really need to look at this unless you want to. Do you remember how to solve graphically?
Yes.
You type it in. So, okay, we'll just not actually write anything down. Let's grab our calculators and just practice one last time and we're done. Okay? I know we're warm. Okay, so y equals, first equation, 600 plus 5x. Second one, 25x. Now, will our regular windows work? No, if you push graph, you're not going to see anything. I don't think anything. No. But do they give us windows? Do they give you a graph? Yeah, so let's just match what's there. You can barely see one line. There you go. Okay, so let's match it. X was going from 0 to what? On the graph it's given. So push the window button. What do we see on the graph that's given? X is from 0 to 50. And they're going up by how much? 10. Okay, y goes from 0 to, actually goes negative 100, but let's go 0. To, how high does the y go? What large number do you see on the graph? 1,000, and it goes up by 100. Okay? So if you're given a graph, you're given your window settings. Isn't that nice? Yeah. So back to my window settings. I did 0. I just did 0. We also negative 10. So 0 to 50, and then scale is 10. It's going up by tens. And 0 to 1,000, and they're going up by hundreds. Change our windows. Okay? All right, we good? We got the graph.
Yes.
Okay, so how do I graphically find the intersection point? Second trace, 5, enter, 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 and there it is, 30 and 750. Now, you have to remember who is x and who is y. So if that's my intersection, is n the x variable or the y variable? N is which one? N is your x, right? Because x was to be used as x, and then this would be d. Y was d. It even says it on the graph. Okay? So that would answer your question if we actually read through it. When you're because you're talking about, this question's asking about profit, right? Cost and revenue. So cost for the sweater, and then money you're taking in for the sweater. This is when you would break even. When your cost to make them equals the money that you spent. So break even point, you need to make 30 sweaters and bring in $750. You make 30 sweaters, you break even. Anything above 30, you're raking in the dough. That's profit. Okay, it's 2. Your assignment. Page 624. Let's circle. 2. 2, 3 AC.
Question.
Wait.
There is no 3 ACs.
Oh, oops. I wrote down the wrong lesson. Ignore this. It's actually 1 to 6, 8, and 9. All of 1 to 6. 3, 4, 5. 5, 6. No. 1 to 6, and no 7, and then 8 and 9. Well, no 10, and no 11.
Yeah, okay, but that's, we're only not doing 3 questions.
Yeah, but it's easy, isn't it?
Yeah, but still.
You're making y equals. Okay.
That and it looks like
18 minutes. It's a record short lesson.